What is the difference between shallow copy, deep copy, and normal assignment operation? I get the following results. If I perform deep copy, results are the same. If I work on assignment operations, then results are. Can somebody explain what exactly makes a difference between the copies? Is it something related to mutable and immutable objects? If so, can you please explain it to me?
Normal assignment operations will simply point the new variable towards the existing object. The docs explain the difference between shallow and deep copies. The difference between shallow and deep copying is only relevant for compound objects, objects that contain other objects, like lists or class instances. A shallow copy constructs a new compound object and then, to the extent possible, inserts references into it to the objects found in the original. A deep copy constructs a new compound object and then, recursively, inserts copies into it of the objects found in the original. Here's a little demonstration. Using normal assignment operatings to copy. Using a shallow copy. Using a deep copy.
For immutable objects, there is no need for copying because the data will never change, so Python uses the same data, IDs are always the same. For mutable objects, since they can potentially change, shallow copy creates a new object. Deep copy is related to nested structures. If you have list of lists, then deep copy copies the nested lists also, so it is a recursive copy. With just copy, you have a new outer list, but inner lists are references. Assignment does not copy. It simply sets the reference to the old data. So you need copy to create a new list with the same contents.
For immutable objects, creating a copy doesn't make much sense since they are not going to change. For mutable objects, assignment, copy and deep copy behave differently. Let's talk about each of them with examples. An assignment operation simply assigns the reference of source to destination, e.g. Now I and j technically refer to the same list. Both I and j have the same memory address. Any update to one of them will be reflected in the other, e.g. On the other hand, copy and deep copy create a new copy of the variable. So now changes to the original variable will not be reflected in the copy variable and vice versa. However, copy, shallow copy, doesn't create a copy of nested objects, instead it just copies the references to the nested objects, while deep copy, copies all the nested objects recursively. Some examples to demonstrate the behavior of copy and deep copy. Flat list example using copy. Nested list example using copy. Flat list example using deep copy. Nested list example using deep copy.
Let's see in a graphical example how the following code is executed.
A, B, C, D, A1, B1, C1 and D1 are references to objects in memory, which are uniquely identified by their IDs. An assignment operation takes a reference to the object in memory and assigns that reference to a new name. C sadface 1, 2, 3, 4 is an assignment that creates a new list object containing those 4 integers and assigns the reference to that object to C. C1 equals C is an assignment that takes the same reference to the same object and assigns that to C1. Since the list is mutable, anything that happens to that list will be visible regardless of whether you access it through C or C1 because they both reference the same object. C1 equals copy.copy, C is a shallow copy that creates a new list and assigns the reference to the new list to C1. C still points to the original list. So, if you modify the list at C1, the list that C refers to will not change. The concept of copying is irrelevant to immutable objects like integers and strings. Since you can't modify those objects, there is never a need to have 2 copies of the same value in memory at different locations. So integers and strings, and some other objects to which the concept of copying does not apply, are simply reassigned. This is why your examples with A and B result in identical IDs. C1 equals copy.deepcopy, C is a deep copy, but it functions the same as a shallow copy in this example. Deep copies differ from shallow copies in that shallow copies will make a new copy of the object itself, but any references inside that object will not themselves be copied. In your example, your list has only integers inside it, which are immutable, and as previously discussed there is no need to copy those. So the deep part of the deep copy does not apply. However, consider this more complex list. E equals 1, 2, 4, 5, 6, 7, 8, 9. This is a list that contains other lists. You could also describe it as a 2-dimensional array. If you run a shallow copy on E, copying it to E1, you will find that the ID of the list changes, but each copy of the list contains references to the same 3 lists, the lists with integers inside. That means that if you were to do E0.append 3, then E would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But E1 would also be 1, 2, 3, 4, 5, 6, 7, 8, 9. On the other hand, if you subsequently did E.append 10, 11, 12, E would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But E1 would still be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's because the outer lists are separate objects that initially each contain 3 references to 3 inner lists. If you modify the inner lists, you can see those changes no matter if you are viewing them through one copy or the other. But if you modify one of the outer lists as above, then E contains 3 references to the original 3 lists plus 1 more reference to a new list. And E1 still only contains the original 3 references. A deep copy would not only duplicate the outer list, but it would also go inside the lists and duplicate the inner lists, so that the 2 resulting objects do not contain any of the same references, as far as mutable objects are concerned. If the inner lists had further lists, or other objects such as dictionaries, inside of them, they too would be duplicated. That's the deep part of the deep copy.